This meeting is being recorded.
For problem 9 from chapter 15, we're given the compound ethyl 3-ethoxypropanoate, and we're told some information about its use as a solvent with polymer preparation. And we're asked here to determine the chemical shift for each signal in the proton NMR spectrum of this compound. So we would begin by first determining the number of expected signals. So if we work through, we would see 6 distinct signals. So we would see one with these 3 methyl protons here. We would see a second signal with these methylene protons. Moving over here, we would see a third signal, a fourth signal. So both of these 3 and 4 are methylene protons. The fifth signal, another group of methylene protons, and then the sixth signal would be from these 3 methyl protons. So let's work through. We'll start with our first signal. So again, 1, 2, 3, these methyl protons over here. So we'll start, we'll number them, number 1, and we begin with a 0.9 ppm shift for methyl protons. We see that they are beta to this oxygen here. So we're going to add 0.5, so 1/5 of 2.5. And we would expect our shift around 1.4 ppm. And let me change color here. So I'll put the actual shift in parentheses here. So we actually see at the same, I'm sorry, at a very close value, 1.2 ppm. All right, let's take a look at these 2 methylene protons here. So we start these in our second group at 1.2 ppm. We see that these 2 protons are alpha to that oxygen, so we're going to add 2.5, and we expect a signal around 3.7, and our actual signal, we're told, is around 3.5. So again, these are predictions, so we can come close to our expected values. So when you're looking at a spectrum, you can actually predict and then match up these signals to the expected protons. So now we have in our group 3 here, again, we have methylene protons, so 1.2 ppm to start. Then we're going to see that these are alpha to the oxygen, so we're going to add 2.5, and these are actually going to be beta as well. So here's our alpha carbon, here would be beta to this carbonyl. So we're going to add an additional 0.2, I'm sorry, an additional rather 0.5 to our, oh no, I'm sorry, it was 0.2. So we add, again, 1.2, 2.5, and then 0.2, because that is 1/5 of our signal of a carbonyl, so 1.0. And we add these together and we see an expected signal around 3.9 ppm, and then our actual signal is at 3.7. Okay, so let's move to our fourth group here. So now we're down here, these 2 methylene protons in, we'll number this group 4. So they begin at 1.2. They are alpha to a carbonyl, so now we're going to add that full 1.0. And then these protons are also beta to that oxygen over there. So we're going to add an additional 0.5 here. So we have approximately 2.7 ppm for these 2 protons, these methylene protons, and their actual signal is very close at about 2.8. All right, let's move to our next group here. So now we have group 5 protons, and these 2 are again methylene. And now we have to add being alpha to an ester oxygen, so that adds that 3.0 ppm, and we would approximate our signal to be around 4.2, and our actual signal is the same. So this 4.2 is the same. So our calculated, our approximated, and our actual signal. So our last group here, we have our 3 methyl protons, and we know we start methyl protons at 0.9 ppm shift, and then these are beta to that oxygen there, and 1/5 of that 3.0 for an ester oxygen will be 0.6 ppm that we add. So 0.9 plus 0.6, we expect a signal around 1.5 ppm, and then our actual signal is once again fairly close, around 1.3 ppm.